Hello dear students, I am Samir Velankar. I welcome all of you to this another video of linked list data structure, and we are now continuing with the same video which would be left out in the previous video about the circular linked list operations. We were learning a program of circular linked list, and in the now after, let's say we have inserted 4 nodes. In main, we have called insert node 4 times, and we have inserted 10, 20, 30, 40. Now we would like to display the list, display the circular linked list. So we have called a function called display, and notice to display function we have passed only address of first. You will notice we don't have to pass last. As you see in the insert node, we were passing last, but you don't have to pass last here, because our plan is we will be displaying the list from first, and we will stop when we get a node whose next pointer is pointing back to first. Okay, let's see what I mean by this. But display function is called, so let's go to display function. Here we are, and you know this p is a pointer to pointer which stores address of first. So assume that we have created a list like this: 10 whose next points to 20, whose next points to 30. Okay, and enough. Let's imagine we have inserted only 3 nodes. So next of 30 points back to 10. We have first pointer which always points to the very first node, and last pointer was kept here which was pointing always to the last node. Now you know that p stores address of first. So you know p is a pointer to pointer and p points to first. From now onwards, asterisk p is same as first. So we can access first pointer inside the display function using the notation asterisk p. Now let's see how to display this circular list. You know what's the challenging part in displaying the circular list is, like you just go back in the memory. How did we display? What we did is we asked a temp pointer to point to 10, first node. Then we displayed the data. Then we asked temp pointer to point to next node by saying temp equal to temp arrow next. Then we displayed 20, the data at which temp is pointing. Then we asked temp to point to next node. Okay. And then we displayed 30. And then when we asked temp to point to next node, observe in a singly linked list, this next pointer was null. Singly linked list had a terminating symbol, that is null. So when temp here became equal to temp arrow next, temp became null. This temp became null, and that is why go back to singly linked list and see the condition written in the while loop was temp not equal to null. So when temp becomes null, we stopped. But the problem in a circular linked list is we don't have a null pointer as a terminating symbol. So if we write such a condition, same condition in a circular linked list display, that continue as long as temp is not null, hello temp will never become null, because there is nothing called null pointer over here. You cannot find any null pointer here. So we need to write some other type of condition over here. Let's see what we are going to do. Let's start with the function. In the function, we declare a temp pointer and ask temp to start at first, temp equal to first. So temp will point wherever first is pointing. Now let's go in a while loop, and this while will continue. This while will continue as long as temp arrow next is not equal to first. You see, what is temp arrow next now? Follow the cursor. Temp arrow next, this next is address of 20. That is, it is second node. Then temp arrow next not equal to first is true, isn't it? Because temp arrow next is not pointing to first node. Temp arrow next is pointing to second node. So not equal to first is true. So we will enter the while. If we enter the while, we are going to print temp arrow data, right? So temp arrow data printed, the first output will be 10. And then we say temp, you better go to the next node. Temp equal to temp arrow next. That means temp will point to the second node, which is 20. Temp becomes equal to temp arrow next. So temp points at 20. Okay, time to go back to while now. Let's go back to while. If we are back at while, we inspect the condition. What is temp arrow next? Is it still not equal to first? You observe what is temp arrow next. Follow the cursor again. Temp arrow next. Check this. Temp arrow next. This next we are talking about. This next is pointing at 30. So temp arrow next is not pointing to the first node. So not equal to is true. Hence we go into the while again and print temp arrow data. So temp arrow data this time is 20. And then temp advances to the next node. Temp is equal to temp arrow next. So now temp is going to point to the third node. Temp equal to temp arrow next. This is fun now. This is it. Now let's see what happens. Now when we take an entry in the while loop, again, we ask what is temp arrow next. Check this condition. We ask what is temp arrow next. Is it not equal to first? But hello, check temp arrow next. Temp arrow next. This next is indeed equal to first, isn't it? It is pointing wherever first is pointing. It is equal to first. You observe both first and temp arrow next are pointing to the same node. Then not equal to is false. In fact, temp arrow next is equal to first, so the loop breaks. So what is the terminating condition for circular linked list display? We will say keep displaying the node, keep displaying the node, go to next node, go to next node. But stop when you reach a node whose next points back to the first node, isn't it? So we are out of the while loop. But you observe the output written down below there. The output has not shown 30. You understand, I'm sure. Because as soon as we reached 30, the loop stopped. So we were not able to print it. So after the while loop, when the loop stops, we are sure that we are at the last node, isn't it? So we are out of this while. Let me clean the slate. When we are out of while, we know that temp is pointing at the last node. So out of while, once we come, we again print temp arrow data. And now you know temp arrow data is 30. So 30 gets printed, and that's the end of display function. So slight modification, I repeat, in linear linked list, not circular one, which we saw earlier, the condition was while temp is not equal to null, because we know if temp goes node after node, then after some time temp will fall down, temp will become null, because in singly linked list or in a simple linked list, we had last node having next equal to null, but we don't have that sort of condition here. So hence we have written continue as long as we reach a node whose next is pointing back to first. If next of a node points back to first, then stop the loop and print the last node. Of course, this hard work you will have to do. At the end of while, we will have to print that only node which was not printed. I hope you have got enough of it. The display function is done. Now I am going to leave one work to you. I am just going to give you an idea how to delete a node from this circular linked list. Just check the idea from me and then go through the delete function on your own. I have given the code below display over here. Here is the delete node function. The delete node function will delete some value x from the list. So how are we going to delete a node? Let's see. The argument that or the description that we can make is, let's say again that we have 10, its next points to 20, its next points to 30, next points to 40. Let's have a bit bigger list, and 40's next points to 50. And you know next of 50 points back to first. If 50 is the last node, first always points to the very first node and last points to last node. Now imagine we want to delete 30. What if we want to delete 30? Then we will have to first search 30, isn't it? For searching 30, we will use two pointers A and B, just as we used it in singly linked list. So what we will do is we want to search 30 because we want to delete 30. Then we will start A and B both from the first node. And this A and B will work in such a way that A will always go ahead and B will remain behind by one node. So B will be always behind A by only one node. Let's see. Once A and B are at 10, we will ask this node, wherever A is pointing, are you storing 30? And this node says, I am not storing 30. So surely this is not the node we want to delete. So we will ask you better point to the second node because first node is not storing 30. So you point to the second node. And once A points to the second node, B will very, very carefully follow A. B will say, okay, A has advanced, so I will join A. I will also point to the same node. Isn't it so? Now you see the data is still not 30. So we will ask A, you better point to the next node, isn't it? Now, when A reaches this node, we see that the data is 30 and we want to delete this, isn't it? But you note A is pointing to 30, the node which we want to delete. A is pointing there, but B is pointing to its predecessor, 20. And then we are only one line away from deleting 30. We can say B arrow next, that is 20 is next. 20 is next, should point to A arrow next. Where is A arrow next? A arrow next is pointing at 40. So B arrow next should point wherever A arrow next points. Then you can see 30 is as good as deleted because if you now trace the list, 10 is going to take us to 20 and 20 is going to take us to 40 because the next pointer association of 20 with 30 is broken and 20's next is pointing to 30, to 40. So 30 is bypassed. We can, of course, after doing B arrow next equal to A arrow next, we can call for free A. What will free A do is it will actually return the memory to which A points. So this 30 and the node in which it was stored will be released. So we are no more consuming that memory anymore, isn't it? But there is more to this actually. I am asking you to just go through this delete node function code on your own, but there is more to this. What if user says that user wants to delete 50? You may say, what's extraordinary about that? Come on, this is an extraordinary situation. If we want to delete 50, then it's not so easy like bypassing a node. When we wanted to delete 30, we simply bypassed 30. We said 20, you are pointing to 30, now don't point to 30, point to 30 is next, which is 40. So 20 pointed to 40. But if we want to delete last node, then we will have to deal with this quite differently, isn't it? So what we will have to do is, if you want to delete 50, isn't it? If we want to delete 50, then you know that B will be pointing at 40 and A will be pointing at 50. Because what happens when we want to delete any node? Searching is done and searching will position A at 50 because we want to delete 50 and B will be always at predecessor. I hope you are understanding. B will be always behind A by one node, correct or not? And now we will have to say B arrow next equal to first. B arrow next should point wherever first points. When should we do this? When we are deleting the last node. Notice A is pointing wherever last is pointing. So B arrow next should point back to first, correct? And one more change we will have to do. We will have to say last. How can you point to 50 now? Last can't point to 50. But last should point wherever B is pointing because 40 has become the last node. And then we can call free A. If we call free A, it will free the memory to which A points. It will free this memory, isn't it? To which A points. So such condition for last node deletion has to be very carefully followed. And that's what has been written in the delete node function. or I would just advise all of you to go through this, or you can come up with your own version of delete node. You can Google search how to delete a node from a circular linked list, and you can just come up with some new idea. And when we will meet maybe on live chat, we can have a discussion on how to delete a node from a circular linked list. Thank you very much.